Hashino in 1996 in Journal of Endodontics, and even Windley et al. In Journal of Endodontics in 2005, they all showed that combination of metronidazole, minocycline, ciprofloxacin is effective both in vitro and in vivo at killing common endodontic pathogens from necrotic infected root canals. So now that we disinfected this scaffold that we're going to use, the third thing is, we're allowing growth factors to also contribute in this process of tissue regeneration. As you can see here, the necrotic tissue is disinfected and is lying in the canal, ready to receive all the new stem cells or tissue that is surrounding the apical area. And obviously the fourth thing that is very important is creating a coronal seal. Coronal seal is very, very important. If you have any sort of leakage in the coronal area, you're just wasting your time. Everything that is happening is just going to, lead to failure. And obviously, MTA is the most superior restoration out there that we can definitely depend on. And there are many published reports that validate that. So now that we created this environment, we have disinfected necrotic tissue, we have an MTA, coronal seal, we can actually lead to tissue formation. So the question that we asked ourselves is, yes, we can regenerate root formation only when the right environment is provided. And this is exactly what happened in the past few years. There are many, many published reports that, again, validated this very interesting and hot topic. So now that all the slides that we just talked about summarize a very important topic, tissue engineering. When you want to form or reform any sort of tissue, you're pretty much utilizing the concepts of tissue engineering. So if any one of you wants to start or perform this therapy, it's very important to have that in mind, so it can better direct you into the right path, basically. So what is tissue engineering? It was defined by two individuals. Langer, in the Journal of Science in 1993, he defined it as the interdisciplinary field that applies the principles of engineering and life sciences toward the development of biological substitute that restores, maintains, or improves tissue function. A more summarized definition by MacArthur in Journal of Nature in 2005, he stated that tissue engineering is basically the understanding the principles of tissue growth and applying this to produce functional replacement tissue for clinical use. So let's look at the key elements that are required for this process to occur. Reddy in 1998 and even Nakashima and Reddy in 2003, they outlined three very important elements that are required for tissue engineering. The first thing is stem cells, extracellular matrix, and growth factors. So let's look at stem cells. Stem cell is basically a cell that has the ability to continuously divide and produce progeny cells that can differentiate into specialized cells. And there are commonly two kinds, embryonic or postnatal. I guess the difference is if it's embryonic, you take it from the embryo or the umbilical cord. And if it's postnatal, it's taken any time after that. And one difference that is very important to note is basically with embryonic stem cells, you have something called plasticity. Plasticity is higher in embryonic when compared with postnatal. And what that basically means is the ability of the cell to differentiate into specialized cells that are various. It's not just one or two cells. It's not just cartilage or connective tissue or fat. It's more than that. It can pretty much differentiate into whatever cells you want. But obviously we're dealing with postnatal stem cells here. So what are the sources of dental stem cells that are available? We have four main sources. The first source is the dental pulp. Then we have the periodontal ligament. And then we have apical papilla. And this is what we need to focus on today because we're trying to activate these guys. A fourth source of stem cell is basically shed. Shed is pretty much stem cells of human exfoliated deciduous teeth. It was isolated for the first time in 2003 by Mura et al. And this is definitely a very promising sort of field that we hope that we're going to hear more and more innovations in the future. So if I ask you a question, is there a difference between the stem cells of the apical area of mature teeth or mature roots versus immature roots? To answer that question, let's look at a very recent publication by Leiji et al. And what he did is he compared the dentinogeneration capacity between immature molar roots of mice or rat versus mature molar roots of rats. And the findings that he found is obviously very interesting and sort of intuitive. He pretty much found that stem cells from